Welcome back to the Gilder Fellows 2020. I'm Jay Richards with the Discovery Institute, and our next presentation is by Professor Gale Pooley. Gale is a friend, is a professor at Brigham Young University, Hawaii, which is, if you're going to pick a gig, that sounds like a really great gig. But he's from Idaho and went to Boise State, University of Idaho, and his PhD is from the University of Idaho, and he teaches economics and business, and he's doing work with the Cato Institute and the Human Progress Initiative with Marian Tupy called the Simon Abundance Index. I know they're working on a book, and they have issued a report. And he's going to talk about this today, and afterwards we'll take questions just like we did in the Q&A function, but he's going to introduce the Simon Abundance Index to us this morning. So Gale, take it away. Thanks.
All right, thank you very much. Great opportunity to be here today. Thank you, Discovery Institute and George Gilder, for this great experience to be here. Defeating the ideology of scarcity by thinking in time. So for the next 45 minutes or so, what I'm hoping is that I can share with you something that 99% of the world does not understand. And this will be some analytical tools and a methodology that will let you see the world in a new way, and a very powerful way. What I want to first of all recognize my co-author, Marian Tupy, with the Cato Institute, who has helped me to develop these ideas. George Gilder will tell you that wealth is knowledge, growth is learning, and money is time. Our work really focuses in on this third principle, that money is time. I don't know if you realize this, but George actually explained this principle to Dr. Strange, and he gave him this time stone to help him understand that money really is time. And we're going to use that to help us to think in time. Thinking in time is really what this idea is about. You see, when you buy things, we buy things with money, but we really pay for them with our time. Henry David Thoreau said, the price of anything is the amount of life you exchange for it. So money prices are expressed in dollars and cents. Time prices are expressed in hours and minutes. The way do we think about this? Time price is simply the money price divided by your hourly income. So for example, if your money price for something is $20 and you're earning $10 an hour, your time price would be simply 2 hours. Okay, let's see how this works with a barrel of oil. 2010, a barrel of oil, the money price was around $75. By 2019, had fallen to $60. So the price had changed by 20%. So the question is, what would the time price be? Well, in order to calculate the time price, we have to know what hourly income is. In this case, if hourly income was $15 an hour, the time price would be 75 divided by 15, or 5 hours. Now, let's assume that in 2019 that your hourly income had actually increased by 33% to $20 an hour. What would your time price be? Well, 60 divided by 20 would be 3 hours, right? So the time price looks like it has fallen by 40%. So here's a question for you. Which one of these numbers make more sense? 20% decline or a 40% decline? We think that the 40% is actually much more accurate in terms of what's going on. So time prices, they have a number of advantages. We've got over 180 different paper currencies on the planet today. And George will tell you that there's a $6.7 trillion daily foreign exchange market. This market is very unproductive and very disruptive to a global economy. We don't know actually how many other digital currencies are out there, but we have this huge currency issue of trading in different currencies. How do we really value things when we have all this going on? So with time prices, the other advantage is really the first advantage is they really fully capture innovation, because when innovation happens, it not only reduces prices, but it also increases hourly income. So when we're considering both the price change in prices and changes in hourly income, we're capturing both of those effects of innovation in this one value, this one variable. The second thing that makes time prices much more helpful is that we don't have to deal with any of these subjective and contentious deflators like CPI or PPI or purchasing power parity. We can ignore all of those things and just go strictly to the time price. And really, the third and probably the most important value of a time price is we are moving everything back to this universal constant of time. This universal constant of time, and is George will tell you in his book, Life After Google, that everything is ultimately measured in time. So being able to take prices back to time allows us to have this universal constant. Recall that Iron Man, Tony Stark, was told by his father that no amount of money ever bought a second of time. And what he meant by this is that time can't be inflated, and it can't be hacked by governments and their central banks. Steve Forbes is fond of saying that the government cannot print more gold. Neither can they print more time. We have this total equality in time where everyone has 24 hours a day. All right, let's look at another example. In 1910, Sears Roebuck was the Walmart of its day. And they would, instead of having the internet, you'd have these beautiful catalogs that they would send you a couple of times a year. You get these catalogs in the mail. And so if I wanted to buy a bicycle, for example, I would pull out my catalog and there was a bike. It was $11.95. Sounds pretty cheap, right? $11.95. Well, what we have to do is ask ourselves, what was the average hourly income in 1910? Well, a website called measuringworth.com, it's probably the best site for tracking hourly income, reports that the average blue-collar hourly compensation was about 18 cents an hour. So what would the time price be? Well, the time price would be simply $11.95 divided by 18 cents, or 66.4 hours. It took somebody 66 hours plus to be able to earn the money to buy a bicycle back then. So let's fast forward to today. If we go to Walmart and we find a similar bike, that bike is about $98. So the price of the bike has gone up, right? About 720%. But we have to consider, once again, what is the time price? Measuring Worth reports that the average blue-collar hourly compensation today is around $32 an hour. So 98 divided by 32 puts you somewhere around 3 hours. So the price of a bike, the time price of a bike has fallen from 66 hours down to 66 hours down to 3 hours. So what does this mean? Well, it means that today we actually, all of us have gotten about 63 hours of free time. Instead of 66 hours, now it only takes 3 hours. We've got 63 hours of free time. The time price itself, the percentage change has fallen from 66 hours down to 3 hours, which would be a 95.5% decrease. Now, most of us have a little trouble when we are trying to calculate what the meaning is of a price decrease. And what we developed is something we call a time price multiplier. A time price multiplier simply says, what was the time price in the base year divided by what is the time price today? So base year was 66 hours. Today it's 3 hours. So that ratio would be 22.1. What this means is the time it took you to earn the money to buy one bicycle in 1910, today you can get 21.1 bicycles. So bicycles have become 22 times more abundant over this 110-year period. So how do we calculate the change in abundance? It's simply going from 1 to 22.1. That's a 2,110% increase in abundance over this time period. If we calculate that on a compound annual growth rate, it's about 2.85% a year. bicycles are becoming 2.85% abundant each year. And what does that mean? Well, at that growth rate, you're going to end up with twice as many bicycles every 25 years. Your productivity will double every 25 years. All right. So the other guy that really inspired us on this study was this guy. And if you remember from Infinity Wars, he says, it's simple calculus. The universe is finite, its resources finite. If life is left unchecked, life will cease to exist. It needs correcting. So where did Thanos get his ideas? Well, in the 1960s, a biology professor at Stanford wrote, society needs rescaling. We've got to reduce the size of the entire human enterprise. Now, what he called for was a reduction of 2/3 of the population. Thanos only wanted to reduce it by 50%. Ehrlich wanted to reduce it by 2/3. So, 1968, he writes this book, and it became a bestseller. It's called The Population Bomb. And this book had lots and lots of consequences in terms of what happened on the planet. It's been catastrophic, especially in China and in India. We've had millions and millions of forced abortions and sterilizations as a consequence of the ideas that were in this book. Now, because of these ideas, we still have these ideas with us today. There are politicians that will say things like, is it okay to have children? The actual father of this idea that we kind of point to was Thomas Malthus. And when he wrote his book in 1798, he said the power of population is indefinitely greater than the power in the earth to produce subsistence for man. And note that there's no reason that this is true. There's no reason that plant life can't grow at the same rate as human life. In fact, what's interesting is if Malthus had actually looked at the data in England for the previous 100 years, he would have found that population in England had increased by 50% over the previous 100 years, but the time price of wheat flour had fallen by 30%. So population increased by 50%, the time price of wheat flour had actually fallen by 30%. So more people were actually making wheat flour more and more abundant. All right, so we've got these three characters, Malthus, Ehrlich, and Thanos. And our argument is that their level of analysis was wrong, that they were thinking at the wrong level of analysis. So Ehrlich, throughout the 60s and 70s, he's making these arguments, writing these books, appearing on TV, talking about these ideas. And there was a little-known economist from University of Maryland that had initially read the population bomb and had agreed with the findings. And he decided, however, that maybe he should check the prices and see what had happened to the prices of these resources over time. And what he found is that the prices had actually been decreasing. They had been decreasing for non-renewable resources like copper and iron ore, and that as population increases, these resource prices had been falling. So he challenged Ehrlich on the data, and we have this contention that occurred between these two over the 1970s. They're going back and forth, having this dispute. It was really this war of theories. Now, both Ehrlich and Julian Simon was the economist, believed that there was a relationship between population and prices. And what Ehrlich argued is that as population increased, that prices would increase, resulting in scarcity. Simon, on the other hand, argued that no, as population increases, prices would actually go down and we would have abundance. So they're arguing back and forth throughout the 70s. And finally, in frustration, Simon says, Ehrlich, why don't we bet? Let's bet on the future. Tell you what, you pick whatever commodity you want and whatever time period you want. We'll put $1,000 on the table and we'll see what happens in the future. So Ehrlich took him up on this bet. He picked 5 metals: copper, chromium, nickel, tungsten, and tin. And they created a contract for $1,000. And it began in 1980, and the period was 10 years. And these 5 metals represented what we call the bet. And so what do you think happened from 1980 to 1990 to these 5 metals? What do you think happened to the price? Well, behold, one of the most important checks ever written in economics. The inflation-adjusted price had fallen by 36%. Some of the metals had actually fallen by greater than that, but the overall prices had fallen by 36%. So our research really said, well, what would happen if, and some people argued that, well, Julian was just lucky, or they just picked the wrong items, that's not really true. So what our research did is we said, what would Julian Simon still win this bet today? Would he still win this bet? So our project involved 5 things. First of all, we developed a definition of abundance, a new definition. Instead of just 5 commodities, we extended the data set to 50 commodities. Instead of just considering 10 years, we considered 38 years. We also converted these prices to time prices. Once again, time prices are a much better reflection of what's really occurring. We think that a time price is really the true price of what's happening. We also developed something we call the price elasticity of population. As population changes, what happens to prices? And then we take all this and we put it into this index that we call the Simon Abundance Index that captures what's happening to population and what's happening to the time prices of these 50 commodities. And we index that based on 1980 being our initial year. So we defined Simon Abundance as this relationship between population and time prices. Just as Ehrlich and Simon had argued, there's a relationship between these two. That's what we also agreed with. So what were the 50 commodities? Well, we had food, fuel, materials, and metals. So we have energy from oil to coal. We have food from bananas to corn. We have materials from lumber to cotton. We have metals from aluminum to zinc. So we looked at all of these prices. Now, fortunately, the World Bank and the IMF and the Bureau of Labor Statistics all keep very good track of the prices of these commodities. So we're able to go to these sources and get their data on the nominal prices of all these commodities back to 1980. Now, remember, we have the prices and we've got to divide the prices by hourly income. And since we were looking at global or world prices, we were trying to calculate what we believe to be an estimate of global hourly income. And the way that we did this is we looked at the GDP per total hours worked. And how this worked is we went to the World Bank, and they keep track of GDP by country. And there's also another organization that tracks annual hours worked. The Conference Board does that. So if you have a country's GDP and you also have their total annual hours worked, if you divide those two, you get this GDP per total hours worked. So what we found is that in 1980, when we began the study, the the GDP per hour worked was about $3.24. And today it's around $16.50. So there's been a little over a 400% gain in this GDP per total hours worked. So with the nominal price and the hourly income, we can now calculate all of these time prices for all 50 of these commodities over this 38-year period. So we have 1,900 data points that we look at. So let's take a look at wheat, for example, one of our commodities. So 1980, to buy a metric ton of wheat was about $173. The GDP per total hours worked was 324. So the time price was 53.4 hours. In 2019, the price had gone up slightly to about $202. a ton, but our GDP per total hours worked had increased to $16.49. So the time price had decreased down to 12.2 hours. So the percentage change, once again, nominal price goes up 17%, but our income is going up by 400%. So the time price was actually fell by 77%. So what does that mean? Well, before we do that, let's take a look at this. Here's the time price chart for wheat over that period of time. Now note that there are periods when the time price will go up. And Julian, Simon, and other economists say, well, that's to be expected. You'll have temporary supply and demand conditions in those markets that will cause the price to go up. Recall that there are 4 things that happen when a price goes up. The first thing is that people use less. The second thing is people will try to find more. The third thing is they will look for substitutes. And the fourth thing is that they will recycle. These 4 things, when you put them together, will ultimately cause that price to go down. The important thing to note here is that underlying trend is a continuous downward increase in abundance. As the price goes down, we can think of that as abundance also increasing. All right, so time price multiplier, recall what that is. It's the time price in the base year divided by the time price in the current year. If we take that 53.4 hours divided by 12.2 hours, we get 4.37. What does 4.37 mean? Once again, it means the time it took you to earn the money in 1980 to buy 1 unit of wheat will now get you 4.37 units of wheat. So the wheat is actually increased in abundance by 337%, right? Start with 1, go to 4.37. That's a 337% increase in abundance. If we look at that over that time period of 39 years, we'll get a compound annual growth rate of about 3.95%. If we take that, if something's growing at that rate, what it means is that you will double something in size about every 18 years. So wheat has become twice as abundant every 18 years for the last 38 years. All right? Okay, so here's the chart for you. There's all 50 commodities, a line chart of all 50 of those commodities from 1980 to 2019. Notice the red dashed line is our index for, we start all of them at 100. So you'll note once again that there are a couple of commodities that actually went above 100 for periods of time. Today, however, there are not one of those 50 commodities that is more expensive than it was in 1980. In fact, there's the average of all 50 of those commodities, and that time price has fallen by 74.2%. 74.2%. Well, what's that mean? Once again, if something falls in price by 74.2%, that would indicate a multiplier, a time price multiplier of 3.87. So your abundance is increased by 287%. Your compound annual growth rate is 3.62%. So you're doubling abundance every 19.4 years. So every 20 years, you're getting twice as much of this stuff for the same amount of effort in terms of your time. We'll give you a shot of this. If you go to this website, we'll actually link to it later in our seminar. That will take you to the Simon Project at the website. They'll have all of this data for you. There'll be some interesting charts and tables for you. Here's a chart that shows this kind of the top half of that chart, showing the 50 basic commodities. And we have 5 variables that we explain here. The percentage, coffee, for example, it actually became really, really abundant over the last 39 years, almost 87% more abundant, which means that the abundance multiplier is a 7.6. The way to think about that is that the time it took me to buy 1 cup of coffee in 1980, I get 7.6 cups today. On a compound annual basis, that's about a 5.5% increase in abundance. Every 13 years or so, you would double the number of the amount of coffee that you could buy for the same amount of time. So take a look at that chart if you get a chance to. We also have a table there that shows where all the detail comes from. So you can look at each commodity, where the nominal price was in 1980 and today, the percentage change in the nominal price, and then the rate per per hour, the time price, and then our calculations here. So take a look at that. All right, so back to this idea of where we were with Simon and Ehrlich. So our population from 1980 to today has increased about 73%. We were about 4.5 billion, 4.45 billion to 7.6. We've added 3.2 billion people to the planet over this period, but time prices have fallen by 74%. Yeah, and this leads us to this new measure that we call the price elasticity of population. The price elasticity of population, what we discovered is when you increase population by 1%, what you'll find is that time prices decrease by 1%. And this is quite a surprising thing that we discovered when we were doing the study. We didn't expect this to happen, to see this relationship. What this means is since 1980, for every 1% increase in the population, that abundance has increased about 3.92%. So increase human population by 1%, increase abundance by 4%. So it was a pretty amazing number that we looked at. All right, so the Simon Abundance Index, we actually take the population, the percentage change in population, and we multiply that times the percentage change in abundance. So it's 1 plus those percentage changes, then we multiply it times 100, so we have this index that starts at 100. So the numbers there, population increased by 73%, so it'd be 1.73, and the abundance increased by 287%, so it'd be 3.87. We multiply that times 100. So our value today is 670. Remember, we start at 100 in 1980, we're now at 670. The way we can interpret that is the planet has become 6.7 times more abundant in terms of the number of people and the abundance of these basic commodities over this time period. There is the chart, shows what's happened to the index. Note once again that some years the index went down. We would have struggles, wars, recessions, and other factors that would cause this abundance index to decline. But overall, look at that trend, that general trend, underlying trend is a continuous upward increase in abundance. So, ready for a quiz? Okay, let's do a quiz. In 1980, you invite 100 of your guests for dinner, and the cost per guest is $10. What would your total bill be? It'd be 100 times 10, it'd be $1,000, right? Now, let's say that today you invite 73% more guests, but the cost per guest has fallen by 73%. What would your bill be? How many say that it'd still be $1,000? How many say that it would be more than 1,000? And how many would say that it would be less than 1,000? Okay. So let's actually do the calculation. Remember, how many guests do you have now? You go from 100 to 173 guests. But what's the price per dinner, the price per plate? It's fallen by 73%. So now it costs you $2.70. So your price for dinner is now $467. Your price for dinner has gone from $1,000 down to $467. Your costs have fallen by over 53%. What we call this is superabundance, where time prices are proportionally falling faster than your population is increasing. And this is actually what we've been experiencing for the last 39 years, is this increasing abundance. Now, why did Simon make this argument? Well, his argument began with this idea that the fundamental value, the most important resource on the planet are human beings, because only human beings are able to have ideas. And these ideas, if they're free to act on them, can become inventions. And when we can take an invention to a free market and discover a value has been created, an invention that has created market value, we call that an innovation. So this process of human beings having ideas, those ideas becoming inventions, and those inventions becoming innovations is really this process that we observe as economists is what's lifted us out of poverty into prosperity, this innovation process. So let's go back and think about another little thought here for you. When you go to the grocery store to buy a loaf of bread, what's more important to you, the number of loaves on the shelf or the price? The number of loaves, you go in and count the number of loaves, or do you look at the price? See, I think it's the price. I think the price contains more information than the quantity. The price contains more information than the quantity. Now, our three characters in the story here, here's what our argument is that they were counting quantities. They looked at physical quantities. They were doing addition. They would add up quantities and they divide by the population and say, oh no, we're gonna run out. Have you ever gone to the store and says, wow, there's only 2 loaves of bread on the shelf. We're gonna run out. Well, that was their level of thinking. They should have done what? Well, they should have not thought about the quantity. They should have thought about the price, because the price indicates relative scarcity or the value. And if they were really thinking deeper, they would have gone beyond the money price and thought in time prices. If they thought in time prices, they would have been thinking about the ratio of the money price divided by their hourly income. They would have been thinking in time. And if they really, really wanted to go to the next level, they would have been thinking in the change in time prices over time. They would have been doing calculus. When Thanos says it's simple calculus, it's like, no, Thanos, you weren't doing calculus. You were doing simple addition. That's where you made the mistake. Because if you had been thinking, instead of thinking of quantity and adding up things, if you had been thinking in the change in time prices over time, you would have come to a completely different conclusion about what was going on. So we name our index in honor of Julian Simon. And our argument is he actually received the Nobel Prize in 2018. And you asked, how did he do that? Because he died in 1998. Well, the 2 economists that were awarded the Nobel Prize that year were Paul Romer and William Nordhaus. And both of these economists actually did work on the role of time prices and human innovation, the role of how ideas actually are what create value, not things, but ideas. So when we take innovation and we analyze it under this methodology of time prices, we see the world in a completely different perspective, and I think a much more honest and truthful perspective. So one more quiz. How many keys are in a piano? How many keys? I think there are 88 keys. So how many songs can you get from those 88 keys? Well, here's what we think about. Now, if you are a biologist or a politician or a bureaucrat, you're going to count the number of keys on the piano. But if you're an economist, you're going to do what? You're going to think about this infinite amount of music that you're able to generate from just this limited set of keys. We've got a fixed number of atoms on the planet, but the possible way of rearranging those is infinite. In addition to that, we have information or knowledge, and the way that we rearrange that knowledge also creates new value. So I would just tell you that we need to listen to the time price. To paraphrase the great mind of Carver Mead, listen to the time price, find out what it's telling you. Now, we have Julian Simon to thank for this work. Now, I think if he was here today, he would tell us something like, listen to the music, that every human being that's on the planet has really superpowers. And if we are given the freedom to be able to create and the liberty to trade with each other, really the liberty to be able to use our intelligence to be able to act on this information that our economy is really based on, that we'll be able to create all kinds of astonishing abundance. It's all around us, and we will defeat the dark forces of Thanos. All right, thank you.
Gale, that's terrific. So we have a few minutes actually before we take a break, and so I'm going to just try to pick a couple of the questions that we've had. So we've got a lot of good questions. So kind of maybe the simple one first, it came toward the end, but okay, so you've persuasively shown that there's an increase in abundance using this analysis. But is that abundance and value all going to the wealthy? What about this, putative gap between the rich and the poor and the wages? Are the benefits of this abundance going mostly to the 1% and not to the?
Yeah. That's a really good question, Jay. Here's what I would tell you. When you look at these basic commodities, those basic commodities really are a large percentage of the poor's budget. Mm-hmm. Food, for example, right. And energy is related to that. So when we notice that these basic commodities are falling in price, becoming much more abundant, they're really benefiting the poor. Mm-hmm. You and I probably don't care much about what a cheeseburger costs.
I don't know what the percentage of my income is on a cheeseburger. Yeah.
It's trivial amount for us in the West.
Right.
But for somebody in India or these developing countries, that can be a significant portion of their budget. I like to explain this. If you go back to 1960 and you look at what it cost a person in India to earn the money to buy their rice for the day, and you look at somebody in Indiana, mm-hmm. There was a huge difference. Right. They spent 8 hours a day. The person in Indiana was spending 1 hour a day. Mm-hmm. Now, as those prices both fall, as wheat becomes 8 times more abundant and as rice becomes 8 times more abundant, well, we save 54 minutes, but the guy in India, he saves 7 hours.
Right.
So his life is becoming much more abundant because now he's got 7 hours. Mm-hmm. You and I get 55 more minutes, but he has now 7 more hours.
So that's the benefit. I mean, because you focus on these basic commodities. And so the irony is, if anything, this is optimized for the bottom billion, because it's precisely when, at some point, these kind of basic necessities for the wealthy are just it's a tiny fraction of their total income.
Think about a bicycle.
Yeah.
They're 22 times more abundant today than they were in 1910. So
absolutely.
that abundance that really is benefiting it benefits all of us, but especially it benefits those individuals at that level. And the argument that Simon makes is that as you have this increase in abundance, you're really freeing these people to then participate in this learning curve, innovation process.
Right.
They get to come to the table.
That's right.
And bring their ideas to the table.
Yeah, you do different things when you're not spending 70% of your time, just to get the rice to eat.
Right.
Yeah. Well, so there's a question that's sort of the opposite side. So in some ways, you focused, I think in some ways it's wise to focus on these basic commodities because they're easy to track. But of course, there's this other weird kind of abundance that most of us in the West experience in the developed world, which is this weird abundance in technology, especially electronics, right? In which, it's sort of intuitively obvious that there are these kind of the functionality of smartphones and the things that we used to use a compass for, right? They're sort of embedded, but is there a way to use your time price analysis in some ways to capture that? These are non-commodities, obviously.
So, good question. We pick these commodities because they really don't change over time. Now, when you step out of the commodity world and you start talking about this technology world, these guys, and you go, well, what has happened? What kind of abundance has this really created on the planet? And it's hard to do that because we don't have a smartphone back in 1960 we can compare it to. But what we can do is we can look at one of these items today and say, what was it back then? For example, look at a car, a Ford pickup, for example. And you say, the Ford pickup today is not the same one as it was in 1970. Can we make some kind of adjustment? Well, we can do it that way. A better approach would be to say, can you find something that looks like a Ford pickup today? Yeah, go to India or China and you can find something that looks like that. Well, they're about, you look at the time price of one of those today versus the time price in 1970, and you see that we've had a huge increase in abundance in Ford pickups.
Yeah.
The technology stuff, this kind of thing, I think really gives us this opportunity to not only consume things that we could never consume before, but consume it at a price that's almost zero.
Yeah.
Think about a Netflix subscription versus what it cost you to go rent a movie at Blockbuster.
Well, and it's non-rival and it's basically zero marginal cost. I mean, it doesn't cost Netflix. It's not like we're depleting a store of VHS tapes or anything. Yeah. It's absolutely crazy. And so in some ways, you know, it's like, I wonder if more and more of our wealth, at least in the developed world, gets put into these digital creations that obviously have value, but that are hard to track, you know?
Yeah.
Yeah.
It's really hard to say, what is this really worth to you? Because a lot of times I'll ask my students, what would I have to pay you to never use your phone again? To never use the internet again?
It's pretty high.
Is it $1 million? Is it 10 million? You know, some of them say, I wouldn't do it for $1 billion. And I say, well, you must be a billionaire, then, right?
Right, exactly. Yeah, if I maybe I'd do it for $1 billion, I'd just have other people use it for me. Yeah, exactly. Okay, so one other question because we're going to run out of time, but because you ran quickly by it, but you said the sort of virtues of this analysis is that you get away from these subjective deflators, these other ways of measuring. And so say for like non-economists, explain, okay, so what's the key analytic value of this?
What we try to do is you'll hear discussions talking about the nominal price and the real price. Mm-hmm. Well, what's the real price? What's that word real mean? Yeah. It means that we're trying to take the price today and adjust it for inflation. Mm-hmm. The fact that money is losing its value over time. Paper money is losing its value over time. So something that cost $10 in 1980 costs $20 today. Yeah. And it's due to this inflationary effect of currency losing its value. Well, you can ignore all that and say, well, instead of trying to make this subjective adjustment, just simply go back and say, what did it cost in 1980 and what did people earn in 1980?
Right. And so you're using time. You're basically how much time do they use? So you've now got this sort of absolute measure.
Right. Yeah. George calls it this universal constant. Yeah. That everything ultimately comes back to time. So if we can take the price of things and think in time, if we think in time, then we see things in a much different perspective.
Oh no, this is terrific. And so unfortunately we're out of time. If you're a Gilder Fellow, you're going to get some more time with Gale Pooley. Okay. Gale, it's good to be with you and we'll be back. But we're going to take a short break and then we're going to hear from Discovery Institute Fellow Scott Powell about cultural Marxism and some of the problems that we're dealing with. So give us just a short break and we'll be right back.